Hello everyone, I'm Anna, staff front-end engineer on the environments team. Today I want to share with you some recent progress on our Kubernetes integration, which is the interactive actions. Kubernetes UI is one of our team's main focus areas. It is available from the environment page and is configured per environment with the possibility to filter the resources by Kubernetes namespace. The UI provides real-time insights into the Kubernetes cluster state and allows our users to manage their clusters without leaving the GitLab interface where they check their cluster status. Currently, we implemented the most requested actions, such as delete Kubernetes pod, trigger Flux reconciliation, and suspend or resume Flux sync. We are interested in adding more interactivity to our Kubernetes dashboard. One of the upcoming features could be scaling deployments, which would allow our users to edit their replicas manually within the GitLab UI. Do you have any ideas of the Kubernetes action that you'd like to see us implementing? Please let me know or drop a comment or any feedback into the issue. I'll provide a link. This is how the UI looks right now. On the screenshot, you can see my personal project with a Kubernetes dashboard set up for one of my environments. It shows the list of pods with their statuses and some details, the list of Kubernetes services, and the Flux reconciliation state. Each element is clickable, and there is a drawer providing comprehensive details, including the resource-related events updated in real time. We also have pod logs available for each container of a pod. Let's look closer into the implementation details. To make this work, we need two essential parts. One of the core components is a GitLab agent for Kubernetes. This powerful tool provides a secure bidirectional connection between a GitLab instance and a Kubernetes cluster. It consists of two main components: Agent K, which is a lightweight cluster-side component that the user should install into their cluster, and KAS, Kubernetes Agent Server, which represents a GitLab server-side component. This functionality enables bidirectional communication between the Kubernetes cluster and the GitLab instance. With GitLab Agent for Kubernetes doing its magic and providing a secure connection to the cluster, we were able to implement a front-end-driven Kubernetes dashboard. In order to efficiently manipulate the Kubernetes APIs, we created a GitLab cluster client library, which provides access to the Kubernetes APIs, adds useful helpers, and handles the data changes. This library is based on the Kubernetes official SDK, but it's adjusted to function properly in the browser environment. We continue enhancing the library, which now has more custom functionality not provided by the Kubernetes SDK. For example, the Watch API. This is a TypeScript library. Currently, we have 3 active maintainers, including myself. If you are interested in contributing to the project or becoming a maintainer, please let me know. I'll drop a link to the project in my presentation as well. Here is the chart showing the whole flow. You can see how everything starts with a front-end request that is similar to kubectl command. For example, get namespace or delete a pod. This request goes to a Kubernetes proxy containing the agent ID and a special HTTP-only cookie, which is used for authorization. This request gets to KAS, which forwards the agent ID and authorization data to the Rails internal Kubernetes API and receives information on whether the user was authorized successfully with the impersonation data that will be used in an actual Kubernetes API request. If everything goes well, once the Kubernetes APIs return the response, it will go all the way back through the KAS Kubernetes proxy and will be presented on the front end. Let me show you how it looks like on the GitLab UI. Here is my personal project and the environment page with the Kubernetes integration setup. You're already familiar with it from the screenshot. But as I promised you, interactivity, let me show you it in action. This environment has an agent specified, which is installed in my local cluster. The resources on the page are filtered by the namespace. You can see how everything belongs to the Flag system namespace. Let me play with it a little. What I want to do is running a kubectl command from my local cluster to delete all the pods, letting the Kubernetes to recreate it for me. See how the UI reflected all the changes in real time? For a moment, we could see how new pods were getting ready before the old ones shut down and get removed. Now, all the pods are younger. This was the Watch API. It is a smart way to monitor changes in the Kubernetes cluster state. Once subscribed to the Watch request, the frontend will get notified of any updates. It works similarly to the Watch flag that can be added to the kubectl command. We have to keep the connection active and notify the user if it drops for any reason. But it is a nice way of getting updates only when they actually happen without frequent polling. This technology helps us keep the view up to date when user performs actions. The first one that we've added is delete pod. You can reach it through the actions menu in the pod table or within the button in the details drawer. If I click this action, frontend sends a delete request to the Kubernetes API. Then it will recreate fresh pod for me. You can see it here at the bottom. The other action is triggering Flux reconciliation. This may be needed if the user made some changes to the Git repository or the Flux configuration itself and wants Flux to pick up the changes immediately. It could be also helpful during debugging or troubleshooting. For example, when the user wants to verify whether Flux is correctly picking up the updates. To trigger Flux reconciliation, we have this refresh button on the Flux details view. It sends a patch request to the Flux resource API, updating the reconcile requested at field with the current date time. Within my local setup, it happened so fast that we couldn't see the animation, but there is one. It happens within the Flux sync status batch, showing that for a moment it was in reconciling state and then got back to reconciled. Recently, we added the possibility to suspend and resume the Flux reconciliation. Here it is. This is a useful feature that allows the user to control the automatic synchronization between Git repository and Kubernetes cluster. Suspending reconciliation temporarily stops Flux from applying changes from the Git repository to the cluster, while resuming reconciliation restarts the process. This feature was suggested by one of the GitLab engineers who uses Kubernetes dashboard for their pet project. Once they opened to feature request issues, there was also interest from our customers, and the feature got prioritized by our team. Suspending Flux reconciliation can help in scenarios when the user needs to prevent automatic updates, for example, during maintenance or debugging. If you click the Suspend button, the frontend will send another patch request to the Flux resource API, updating the spec suspend field to true. Once we suspended the reconciliation, we won't have this option again. You can see it's now gone, and the Flux sync won't happen as well. We then can resume it by clicking the button with the play icon. We're currently working on making it more visible when the flag sync is suspended by adding another indicator to the flag sync page. These are the most commonly used actions that we've implemented so far. We are open to new ideas and feature requests. In the case of Suspend Resume, it took us one milestone from an idea to creating an issue, refining it, and scheduling and implementing. Give our Interactive Kubernetes integration a try, and let me know if you have any questions. Thank you.